ground fault interrupter, or GFI, is designed to protect people from electrical shock. It works by monitoring the current flowing through the hot and neutral conductors of a circuit. If the current flowing through the hot wire does not equal the current flowing through the neutral wire, the GFI assumes that some of the current is leaking to ground. This leakage could be due to a faulty appliance, damaged wiring, or a person coming into contact with a live wire. When the GFI detects this imbalance, it quickly trips the circuit, cutting off the power and preventing a potentially dangerous electrical shock. The threshold for tripping is very low, typically around 5 mA. This sensitivity ensures that even small ground faults are detected and addressed before they can cause harm. In the scenario described, involving an adapter that combines a 30 A 240 volt service and a 20 A 240 volt service to feed a 50 A receptacle in a recreational vehicle, the GFI will likely trip as soon as the adapter is plugged into the feeder. This is because the two services, the 30 A and the 20 A, are not balanced. The current flowing in the hot wire from the 30 A service will not be the same as the current flowing in the neutral wire from the 20 A service. This imbalance creates a difference in current between the hot and neutral conductors, which the GFI interprets as a ground fault. Even without a load connected, the inherent configuration of the adapter creates a condition where the currents are unequal. The GFI is designed to react to this condition immediately, thus tripping the circuit. To understand this better, consider how a standard 240 volt circuit works. In a typical 240 volt circuit, there are two hot wires, a neutral wire, and a ground wire. Each hot wire carries 120 volts with respect to the neutral, and the two hot wires are 180 degrees out of phase. This means that when one hot wire is at its peak positive voltage, the other hot wire is at its peak negative voltage. When a 240 volts appliance, such as a dryer or an electric wrench, is connected to the circuit, it draws current from both hot wires. The current returns to the source through the neutral wire. In a perfectly balanced 240 volt circuit, the current flowing through each hot wire is equal, and the current returning through the neutral wire is also equal to the current flowing through each hot wire. Therefore, the GFI sees no difference between the current flowing in the hot wires and the current flowing in the neutral wire, and it does not trip. However, in the case of the RV adapter, the situation is different. The adapter takes one leg from a 30 A 240 volt service and uses it to feed one leg of the 50 A receptacle. It takes another leg from a 20 A 240 volt service and uses it to feed the other leg of the 50 A receptacle. The neutrals and grounds are tied together. This configuration creates an imbalance because the two legs of the 50 A receptacle are being fed from two separate services with different current capacities. Even if the RV is not drawing any current, there may still be a small difference in voltage between the two legs due to variations in the power supply. This voltage difference can cause a small current to flow through the neutral wire, which the GFI will detect as a ground fault. Furthermore, if the RV does draw current, the imbalance will be even greater. For example, if the RV draws 15 amps from one leg and 10 amps from the other leg, the GFI will see a difference of 5 amps between the hot and neutral wires. This difference is far greater than the 5 mA threshold, and the GFI will trip immediately. The statement on the adapter that it will not work on GFI protected plugs is a clear indication of this issue. It acknowledges that the adapter's design is incompatible with GFI protection due to the inherent current imbalance. There are a few reasons why someone might use such an adapter. Firstly, it allows an RV owner to connect to a wider variety of power sources. RV parks often have different types of electrical outlets, and this adapter allows an RV owner to use whatever outlet is available. Secondly, it can be a cost-effective way to provide power to an RV. Rather than installing a dedicated 50 amp service, an RV owner can simply use this adapter to connect to existing 30 amps and 20 amp services. However, it is important to understand the limitations of this adapter and the potential problems it can cause with GFI protection. If GFI protection is desired, it is necessary to use a properly wired 50 amp service. In summary, the GFI will trip as soon as the adapter is plugged into the feeder because the adapter creates an unbalanced current flow between the hot and neutral wires. This imbalance is due to the fact that the adapter combines two separate services with different current capacities. The GFI is designed to detect even small imbalances in current, and it will trip to protect against potential electrical shock. The adapter's incompatibility with GFI protection should be carefully considered before using it. Understanding the principles behind GFI operation and the specific configuration of the RV adapter helps to explain why this issue occurs. Always prioritize safety and ensure that electrical connections are properly made and compatible with the intended use. If GFI protection is required, the appropriate electrical service should be installed.